We're going to work through using mixes in this video, and we're going to jump straight into it. We've kind of alluded to in an earlier video about how mixes work. We're going to apply that right now. So as we take a look at this problem, let's identify our key information. We have a requirement that's 70. Ooh, I hate when I leave this on black. I need a color that shows up. We have a ration that we're looking to solve for 70% TDN. We have corn, we have barley, and we have a grass hay. So that's 3 ingredients. So in this one, what we're going to do is create a mix of corn and barley to create a grain mix. And we generally create mixes out of similar ingredients just to make it a little bit easier. So these are both of the cereal grains. And just assume everything's on a dry matter basis. So what we're going to do is kind of try to figure out what kind of a mix we need to be able to balance this ration. So we know that we've got these 2 ingredients, and they're probably going to be the highest TDN, because when you take a look at this, both corn is 90% and barley is 85%. Both of those are significantly higher than the 50% TDN in the grass hay. So we know that our grain mix is going to be X. The grass hay is going to be everything minus X. So what we're doing is mixing the 2 cereal grains to create one grain mix. And then essentially, we're going to have a simple algebra problem like in the first algebra video that we watched. That's going to be pretty straightforward to solve. And together, those equal 100% of the complete ration. So let's walk through this problem. The first step we have to do is make the mix. Okay, so we're going to take our corn and our barley. And the instructions called for a 50-50 mix. So we know that we have 50% of each one. We're going to assume this mix is out of the dry matter. So what we're saying is that we've got 50 pounds of dry matter of corn, 50 pounds of dry matter of barley. Together, those are going to total up 100 pounds of dry matter. Now we're solving this ration on a dry matter basis, so we're already working in dry matter, so there's no need to worry about converting to as-fed or anything for this particular problem as of right now. So what we want to know is we want to know how many pounds of TDN is in each of these ingredients, because we got to figure out the percent TDN of the grain mix. So that's our goal, is to figure out the percent TDN. That's what we're after. So to do that, we're going to multiply the amount of each feed times its nutrient concentration. So when we looked up the compositional data, I actually gave it to you in this problem, corn was 90% TDN, barley was 85% TDN. We solve for each of these. We have 45 pounds here. We've got 42.5. That gives us a total of 87.5 pounds of TDN. So now to figure out the percentage, that's that, remember the equation, the part over the whole times 100. So in this case, we've got our part, which is 87.5 out of 100 times 100. So that means that our percent TDN is actually this 87.5%. And once you're doing these, and if this is out of 100 pounds of dry matter, that's always going to be your percent of nutrient. But so we were able to create a new mix. We're now going to plug in this new value as a percent TDN into an equation to be able to solve this problem algebraically. So let's go to a new screen. We've got our requirement. We were asked to solve this problem for 70% TDN, so that's the requirement. We're going to add in our first feed, which is the grain mix. So that grain mix was 87.5% or 0.875, and that is the energy source, so we set that to be X, and then we're going to add in the hay. And that hay was 0.5% or 50% TDN, but in this case it's going to be 0.5 times 100 minus X. So now we have an equation that we can solve. It's just got the two feeds because we made that mix. So let's just go ahead and walk through how we solve it. 70 is going to equal 0.875x plus 50 minus 0.5x. Remember, we have to always go through the parentheses. So, as always, I'm also going to make us find our like terms, the x's, and the solid numbers, the whole numbers, whatever you want to call it. Okay? So that when we solve this, we know what we're working with. So we're going to subtract 50 from both sides, leaves us 20 over here. If we combine our like terms, we wind up with 0.375x. Divide both sides by 0.375. That means they're going to cancel out. And we're left with x equaling 53.33% of the ration dry matter is the grain mix. 100 minus x equals 46.67% hay. That's how you use a mix to solve a ration. So like the previous videos, we've got a practice problem for you to try. Oops, sorry. That's kind of our example that we were just working through. Here's our practice problem. You're going to create a forage mix that is 60% dry matter coming from alfalfa hay and 40% dry matter coming from timothy hay, and it gives you the TDNs for those two forages respectively. Alfalfa is 58, timothy's 53, and you have a grain mix that's 79% TDN. So you're going to create a mix of hays and balance it out with a grain mix. Take a shot at this one and see how you do. Pause the video and then work through it, and then click play and I'll work through the solution. So this new mix of alfalfa and timothy hay is 56% TDN. Now you can plug it in and solve the equation. We're solving for 68% TDN. We have our grain mix, which is our X, plus that 0.56, what we just solved for, out of 100 minus X. So we have our hay and we have our grain. Those two together should be 68% TDN when we're done. Oops. So the X terms the whole numbers. Oops, should be a 12. Divide both sides by 0.23. That cancels out. We wind up with x equaling 52.17% grain, because the x was grain, and then 100 minus x equals 47.83 of the hay mix. And again, that's all on a dry matter basis. How'd you do? Please feel free to review. We're going to be working on some specific examples in activity that you will be working on and practicing this skill set. That wraps up this video, and actually the videos for this week.